Hey class, finally to the good part. We're getting back into stoichiometry practice. So let's start off. How many moles of oxygen are in a 35-gram sample of iron oxide? They will give you the nomenclature, so it's up to you to determine which one is which. So they're asking how many moles of oxygen are in a 35-gram sample. So my given is a 35-gram sample of iron oxide. So I know that is iron oxide. So knowing this, I'm going to set it up. So my given is 35 grams of iron oxide. So because I'm going from grams to moles, I know that my conversion factor is going to be 1 mole of iron oxide equals the molar mass of iron oxide. So again, I'm just going to multiply the mass of oxygen times 3, and I'm going to add that to the mass of iron times 2. So the mass for iron that I'm looking at is, I'm going to round up to 56 in case you're solving it on your own. So I look for the mass. The molar mass is going to be 160 grams. So from here, remember, a cross to cross out. So my conversion factor tells me 160 grams of iron oxide equals 1 mole of iron oxide. So I am done with this conversion factor, but I still need to convert from iron oxide to oxygen, right? You have to have that mole to mole ratio to go from one to the other. So here is the last part where I'll be inputting. So I know I have moles of iron oxide, and I need to go to moles of oxygen. So again, because it's mole over mole, this is where we use our mole to mole ratio and we use our coefficients. So I just plug in the coefficient. The coefficient for iron oxide is 2. The coefficient for oxygen is 3, and I am done. I can check my work by crossing out units. Grams of iron oxide, cross out grams of iron oxide. Moles of iron oxide, cross out moles of iron oxide, and I'm left with moles of oxygen, which is what I wanted to solve for. So you multiply across 35 times 3. And then you're going to divide that value by 160 times 2. And you should get something around 0.328, but I'm going to round off to 0.33 moles of oxygen.